Hello and welcome to this video in which I am going to show you how to make use of vectors to calculate the distance of a point from a straight line. To demonstrate this process, we're going to answer this question here. It says that the point P has coordinates -1, 4, 11, and the line L has equation R is equal to 1, 3, -4 plus lambda 2, 1, 3. And the question is to find the perpendicular distance of P from L. Let us suppose that L is represented by this line here. We know that in this form of the vector equation of a straight line, the point 1, 3, -4 actually lies on the line. So let us further suppose that that point is situated somewhere there. 1, 3, -4. Let's further suppose that the point P, whose distance is required, is situated somewhere here. Let me call this point P, and the coordinates are going to be -1, 4, 11. The distance that is required is the distance from P to the straight line, and it has to be the shortest distance or the perpendicular distance. And from that we know that this intersection at the foot of the line is going to be a 90-degree angle. Let's suppose that the foot of that perpendicular is the point H. Now the basis of our argument is going to be based on the fact that the vector P to H, if we could find this vector P to H, it is going to be perpendicular to the direction vector of this straight line here. So let's go ahead and find the vector PH. So PH is going to be the vector O to H minus the vector O to P. Now we know that the position vector of any point on the line is going to be given by this equation here. So let us suppose then that O to H is equal to 1 plus 2 lambda, 3 plus lambda, and -4 plus 3 lambda. Okay, so for some value of lambda, then we would be able to find the displacement of the point O to the foot of the perpendicular H. We also know that the position vector of the point P, O to P, in column vector form is going to be equal to this, the coordinates there. So it's going to be -1, 4, and 11. So if we go ahead then and find what the vector P to H is going to be equal to, it means we are taking this vector here, OH, which is 1 plus 2 lambda, 3 plus lambda, and -4 plus 3 lambda, and we want to minus the vector OP, which is -1, 4, 11. When you do that, in terms of lambda, you'll find that this is equal to 2 plus 2 lambda, -1 plus lambda, and the last component is going to be -15 plus 3 lambda. Okay, so once we have found the vector PH, remember what we have said. We've said that this vector PH is going to be perpendicular to, so the dot product of the vector PH dot the direction vector D of the line is going to be equal to 0. Now let's go ahead and compute that dot product. So I'm going to take the vector PH, which is copying it from there, it's 2 lambda, -1 plus lambda, -15 plus 3 lambda. Okay, and then we require the direction vector of the straight line, which is given by this vector here, 2, 1, 3. So if we compute 2, it is 2, 1, 3. So 2, 1, 3, and that is going to give us 4 plus 4 lambda, and then this component multiplied by that will give us -1 plus lambda, minus 45 plus 9 lambda. and this should be equal to 0, since by definition two vectors are perpendicular, then their dot product is going to be equal to 0. Solving this will tell you that lambda is equal to 3. We are now in a position to work out what the value of the vector ph is equal to. So ph is going to be equal to 2 plus 2 multiplied by lambda, and we found that to be equal to 3, minus 1 plus lambda, which is also equal to 3, minus 15 plus 3 lots of lambda. And lambda is equal to 3 in this particular case again. And this is going to simplify to 8, 2, and negative 6. Now, the distance of the line PH is going to be given by the magnitude of that vector PH. So if we go ahead and find the magnitude of the vector PH, it is going to be equal to the square root of 8 squared plus 2 squared plus minus 6 squared. Okay, and this is going to give you the square root of 104, which is in surd form 2 root 26, which can be given as 10.2 to 3 significant figures. Okay, so this is how you will make use of the vectors to find the distance of a point from a straight line. I trust that you found this useful. Thank you for watching. Cheers.